All right, Mr. Ahmed here for 2.5. Goal for today is writing a proof using segments and angles. Before we actually hop into the proofs, we're going to look at some properties of segment congruence and angle congruence and really kind of discuss the difference between equal and congruent. So equal means an equal sign, okay? So an equal sign is just our two bars, straightforward, and those have a value. We work with numbers that are equal. Congruent is really more referring to shapes that are identical. Okay, the sign for congruence is the equal sign with the squiggly above it. So when we say that those shapes are identical, that would be two angles that I could lay right on top of each other that have the same measure. I could have two squares that are exactly the same size, or two triangles that are exactly the same size. So we really kind of refer to those as congruent as to where our values and numbers are equal. For every property of equality, there's also a property of congruence. So we don't say that segment AB is equal to segment AB. We say that segment AB is congruent to segment AB because they have the equal length. So just like with the reflexive property of equality, any segment is congruent to itself. So AB would be congruent to AB. When we'll use this quite a bit is if we have two shapes matched up next to each other that share a piece, AB. This segment AB would be the same size for both the triangle on the left as the triangle on the right. So we could say that AB is congruent to itself. That's really where that comes into play. Reflexive or symmetric property is two segments. I can switch up the order. If segment AB is congruent to CD, I can switch it and say CD is congruent to AB. So two items again. So reflexive, one item. Symmetric is two items. Switch the order. And transitive is three items that are all congruent. So if AB is congruent to CD, bam, and CD is congruent to EF, CD is the same. So AB would also have to be congruent to EF. They have that one in common. That gets us our new statement. And that's for segments. Same thing applies for angles. Any angle is congruent to itself. Again, that's kind of when we'll see a shape, something like this maybe. Angle A. Angle A would be the same size for the little triangle as it is for the big triangle. Angle A is congruent to itself. One item. Symmetric, switch the order. If A is congruent to B, then B is congruent to A. That's two items. And the transitive property, this one's vital. If A is congruent to B and B is congruent to C, they're both congruent to B, so A would also be congruent to C. We can write a new statement. Three items. Now, with equality, we could use substitution. All right, I could substitute A in for B with an equal sign. I cannot substitute things in with congruent signs. There's no substitution property of congruence. So that's where the transitive property comes into play, is we can't substitute. All righty. So, a couple of reminders of a couple things we already know. Segment addition postulate states that if C is between A and B, going to draw a little diagram here. A, B, C somewhere in between. We can write a statement that says AC plus CB would equal the whole thing. That's the segment addition postulate. I can see that in a diagram. I can write it. Congruent segments, if they're congruent, then they are equal, and vice versa. If they are equal, then they are congruent. So we might have to switch between equality and congruence. All right, so that's when we'll use that statement. Bisector, keyword. If we see that keyword bisect, that's dividing it into two congruent halves. We need to list the congruent pieces. If we are told something is bisected, the next step, list what is congruent. Same thing with a midpoint. If I see the keyword midpoint, I need to go to the next step and list what is congruent. We have to use the keywords, okay? So we're going to use the keyword. It says if point B is the midpoint, there's the keyword midpoint of AC, then what do I know? So I have a diagram here. If B is the midpoint, then AB would have to be congruent to BC. So then I'd write AB is congruent to BC. And the reason why is we use that midpoint. That was the keyword. So we used the definition of midpoint. And I always abbreviate midpoint MP. Definition's abbreviated as well. Next one. This time it says B is just between A and C. So if I just know it's between, I do not know these pieces are equal. There is no keyword there. They're not congruent. So the only thing I can state is that I can look at this diagram and I know AB plus BC is equal to the entire length AC. So I just added up the two parts. AB was the first part plus BC, the second part, that has to add up to the entire length of AC. And what did we use there? We used the segment addition postulate. I always abbreviate postulate, just post with a dot, rather than writing it out. So we are now going to try and actually do some proofs. And a lot of these proofs are going to be very obvious in nature. Like you could probably just look at it and be like, yeah, no kidding, those are equal. I get it. But this is really just more practice for us to get used to showing something is true. So that's our very first geometry proof. And it says given AB is equal to CD. So I'm going to mark that in the diagram. AB is equal to CD. We need to prove that A to C, which I'm going to highlight this, that way it's easier to see. So I need to prove AC, this length from here to here, is equal to BD. So the reason why I say this is kind of obvious is if these two pieces are equal, let's say this is a 5 and this is a 5, BC is the same length for both of them no matter what. Let's say it's 10. So let's just assign some arbitrary values here. 5, 5, let's say this is 10. The length from here to here is 15, and the length from here to here is 15. So it's kind of obvious they are the same length. We just need to prove it, which is not obvious, especially when we don't know how long they are. So starting with what we know is always going to be our first step. Start with our given. AB equals CD, that's what we know. All right, reason number 1 is given. Got a point. Step 2, that's all I got. I need to now look at the diagram and think of what am I trying to work with? Well, I need to get AC into the ball game. He has to be in the endpoint, so what do I know about A to C? From A to C, all right, I know that it's AB plus BC. I can figure that out by looking at the diagram using the segment addition postulate. The two parts add up to the whole thing. So we got AC in the game. All right. Next step, they changed it a little bit here. Instead of an AB, I now have a CD. Well, why can I do that? I can do that because AB is equal to CD, so I can substitute CD in. So now it says CD plus BC instead of AB plus BC. So we substituted that value in. Substitution. So that's another one that's going to get used a lot. Substitution, segment addition, bisector, midpoint. All right, so I got AC in the game. Now we need to get BD in the game. Somehow I need to get BD involved, all right? If I need to get BD at the end, I need to get him into the proof somehow. So when I look from B to D, again, I can use the segment addition postulate. CD plus CB, CD plus CB, or BC, however we want to label it, is equal to the whole length of BC. We use the segment addition postulate. Now, notice these say the same thing. CD plus BC, CD plus BC. Since these are the same, I can substitute AC in for CD plus BC. We could also say that we use the transitive property. I'm going to say we use the transitive property. Two things that were equal to the same thing have to be equal to each other. So I use the transitive property of equality because it's an equal sign, not a congruent sign. If it's a congruent sign, it's the transitive property of congruence. You could have also said substitution here since it was equal. All right, so that's our first proof. A lot of these are going to be fill in the blank for you guys right now. Hopefully come a little bit later on in the year, we'll be able to write these from scratch. But a lot of these ones, this chapter, fill in the blank. All right. A couple other pieces here. This says segment addition postulate. Should say angle. The angle addition postulate states that if C is in the interior of angle ABD, so I'm going to draw this out. I have angle ABD. A, B, D, C somewhere inside of it. There's C. I can add up the measures of the two angles, angle ABC, that's the first one, angle 1 I'm going to call it, plus the other little one, angle 2, which you'd have to name CBD, is equal to the entire thing. We will use that as well. If two angles are congruent, they are equal in measure, and vice versa. If they're equal in measure, they are congruent. We can switch between those. And an angle bisector cuts it in half. So if you are told that an angle is bisected, list the congruent angles. That's our next step. So, other key things from an angle. If angle A is a right angle, then what do I know? If it's a right angle, its measure is 90 degrees. What did we use? Definition of a right angle. Next step says AB bisects. There's the key word. If it bisects, we got to list the congruent parts. So I'm going to draw the diagram here. AB is bisecting angle CAD. CAD is the big one. AB is the bisector, so these two angles are congruent. Put the tick marks in. So I would know angle CAB is congruent to angle BAD. Top one congruent to the bottom one. Reason, definition of angle bisector. That's what we used. So now looking at an angle proof, a couple other terms we have also discussed, complementary, supplementary, those are going to come up. So we need to show that angle 1 is a complement of angle 3. So for angle 1 to be a complement of angle 3, angle 1 plus angle 3 somehow has to equal 90 degrees. What we are starting with is we know that angle 1 is a complement of 2, so 1 and 2 are complementary. So if angle 1 is a complement of angle 2, that is given. I'm also told that angle 2 is congruent to angle 3. Okay, that's also given. All right, next step says 1 plus 2 is 90. Well, 1 plus 2 is 90 because they're complementary. So we use the definition of complementary. I abbreviate that comp. Angles. Complementary. All right. Next step says angle 2 is equal to angle 3. Where did that come from? Well, since they are congruent, they are equal. So we use the definition of congruent angles. Changed it from congruent to equal. Now we need to substitute. Like we said, we need to end with 1 plus 3 equals 90. Right now we have 1 plus 2 equals 90, so I'm going to substitute angle 3 in for angle 2. So the measure of angle 1 plus measure angle 3 has to equal 90 because angle 3 is equal to angle 2. We use substitution. Now we can state that they are complementary because they add up to 90. So we use the definition of complementary angles. And we got it. All right, this video is getting a little bit long. We have 2 examples left. At this point, if you want to hit pause and come back to it later, feel free, but I am going to power through and finish up the video right now. So, next step. M is the midpoint of AB. So, if M is the midpoint of AB, that is our first step. That is given. We are trying to prove that AB is equal to 2AM and AM is equal to 1/2 of AB. Boy, that's a lot of info there. So, well, since this is a midpoint, I know these two are congruent. So I'm going to put a tick mark there. Got that figured out. That is the definition of a midpoint, abbreviated MP. Next step, it changed from congruent to equal, so that's using the definition of congruent segments. I use a lot of abbreviations in this, so congruent sign instead of congruent. All right, now the next one's that came kind of out of nowhere. Where's AM plus MB? Look at the picture. AM plus MB is equal to the whole thing. We are using the segment addition postulate. We'll use that quite a bit. Now we're changing from AM to MB. Well, let's see, where'd that come from? Well, we had MB. AM is equal to MB, so I can substitute AM in. And the reason why I'm doing that is because I want to end up with 2AM. So AM plus AM is equal to AB, and we use substitution, property of equality. And now I would take, if you said combine like terms here, that would work for me, but the book's going to use distributive property for this. And if you said combine like terms, I'd be okay with that. That's fine, but it's actually technically using the distributive property. So that's our first thing we were trying to prove. We got AB is equal to 2AM. That's done. Now the next step is we need to get it to say 1/2 AB. So for us to get it to say 1/2, we will multiply both sides by 1/2. Or you could say divided by 2. I'd be fine either way, but I'm going to use multiplication. Multiply by 1/2. 1/2 AB. 1/2 times 2 is 1, so that's just AM. So we use the multiplication property of equality. And we have ended with what we were trying to prove. So this one, pretty obvious to fill in the blank. But like when I look at this picture, AB, 2AM, well, if these are the same size, AM plus AM, there's 2 of them there. And it also says that AM is half of the thing. Well, that's kind of common sense too by looking. So a lot of these things are very obvious to the eye, but to prove it, a little tougher. And lastly, looking with one angle. So first step, BF bisects AFC. That's given. Now, if something's bisected, we need to list what's congruent. So I need to identify angle AFC by tracing angle AFC. There it is. So if that one was what was bisected, that would mean angle AFB has to be congruent to BFC, which is the second step in the proof. We use the definition of an angle bisector. Okay, next step says CFD is congruent to BFC. That is a given piece of information. So I need to mark that. CFD is this angle. I need to use 2 ticks now because it's not necessarily the same size as that. Is congruent to BFC. CFD congruent to BFC. Well, those are all 3 then the same size. Since these 2 are congruent, those ones were congruent, all 3 have to be congruent. All right, so our next step was a given. And finally, to end with, AFB is congruent to CFD. Well, let's see how we can put those 2 together. AFB is here. And it's congruent to BFC. Here's CFD. So the 2 that we need are both congruent to the same thing, both congruent to BFC. So I can use the transitive property to state that they are congruent to each other for our last step. Now, since this was a congruent sign, we have to use the transitive property of congruence. All right, kind of a long video, but that's it for today. Wraps up 2.5. Have a good one.